Let's continue with debug configuration. So I would just minimize some of the components and let's start with Cortex M4. I would highlight this part. I would click on this down arrow next to the bug icon and I would select debug configurations. I would double click on the last position, so STM32 Cortex M C++ application. It would automatically generate the configuration of the debug process, so this proper ELF file, proper project name. Within the debugger, I would keep most of the settings, but I would just enable this cross-trigger interface, CTI, as we would like to have both cores working synchronously. And within, so I need to apply. Then I go to Startup, and within Startup I would add the configuration from Cortex M0 Plus as well. So Project M0 Plus, Build Configuration Debug, and then I would just remove the load symbols, because load symbols will load within Cortex M0 Plus debug part. Okay, so this is all for Cortex M4 debug configuration. Important point is to have this arrow next to Cortex M4, because we would like to start the project, the code, from Cortex M4 core, as it is in fact activating the Cortex M0 Plus later on. I click Apply. I will not start the debug yet. Click Close, and then I would highlight Cortex M0 Plus, again down arrow next to the bug icon, debug configurations, double click on this last position, and now the same story with Cortex M0 Plus. From first tab, no change. From the debugger, I need to increase the, let's say, port number by one, at least by one, because the first port has been used by Cortex M4, so we need to increase it by one. If we would use, for example, single wire viewer, we would need to increase it by additional one, as the next port number would be used by a serial wire viewer. In this exercise we are not using it, so increase by one is enough. We will not reset the core. We need this cross-trigger interface, so I would select both options. I click Apply, and we will need to modify as well the startup configuration. So I just highlight it and press Edit, and from this I would disable download. This download option is done already within the Cortex M4 debug configuration. I press OK, Apply, and Close. Now we are ready to start a debug session. Okay, let's continue with the debug session. My board is already connected. We can start debug one by one. So at the beginning we are starting already configured Cortex M4 configuration. I start debug. Before activating the code and starting the next configuration, we can configure and run a terminal within our console. So to do this, we can either select already configured console, or we can create a new one by clicking this Open Console and selecting the command shell console. So the connection type, it will be serial port. Connection name, we can select let's say the new name, for example, so it will be Hardware Semaphore Terminal. We will need to select the virtual COM port which is assigned to our board. In my case it is COM12, and as you remember, we have configured our USART2 to 115,000 8-bit data, no parity, 1 stop bit, so exactly the same configuration. I press Finished, and I press OK. After this terminal would be visible within this small monitor icon. If I press this down arrow, I can see this Hardware Semaphore terminal. It is connected. If I select this, I can see already blinking cursor over here. To disconnect, I should use this icon, red icon. The green small dots are used for connection, and to close the console, we need to use this button. So now let's run the code. And as you can see, our Cortex-M4, as this is the only one, is sending the data over USART. So now we can add to this the second configuration. So I go to this small arrow next to the bug icon without stopping the Cortex-M4 core. Debug configurations, Cortex-M0 Plus debug. So now, as you can see, Cortex-M0 Plus is starting execution as well. And now we can see one by one, Cortex-M4, Cortex-M0 Plus. So both cores are working. What we can look here as well is to have a look on the, say, special function registers. So now it is the section for Cortex-M0 Plus, as this one is highlighted. And we can have a look how the hardware semaphores looks like. We are using number 9, and if I would pause for a while, so let's go over here, both are suspended. We can check what we've got within the settings. So within the hardware semaphore 9, it is there is nothing at the moment. And within the Cortex-M4, it is released as well. So let's have a look once we set some breakpoints. So I would put the breakpoint just after, let's say, hardware semaphore take. So maybe in this line, in one core, and in the second core we will do the same. And now we'll try to run the both cores at the same time. So I would press Ctrl and select both cores and try to start them one by one. So now there is interrupt from SysTick. Okay, I landed within Cortex-M4 on this in this area. So Cortex-M4, hardware semaphore. And now if we have a look on this register for hardware semaphore 9, we can see that it's locked. Core ID is 4, which is equal to Cortex-M4, and our process ID is set to 4 as well. So I would try to run it. So now, for example, if I would let's say put the breakpoint over here, so before the semaphore release for Cortex-M0 Plus, and I would go to the hardware semaphore section, I can see that for hardware semaphore 9, I can see the process ID 4, which is common for both, Cortex ID is 8, and lock is 1. Okay, so as we can see, it is working like expected. So now we can terminate debug session one by one and come back to code processing. As you can see, terminal is still working because the code is executing on both cores, so we can observe let's say the activity of the terminal. Thank you for watching this video.